Matt Samore is the program director, principal investigator of our Consortium for Healthcare Informatics Research, which is focused on natural language processing research. And he titled his talk today, Transformative Power of Natural Language Processing of Health Data, Tales from VA. I guess we both named it. So anyway, so for those who don't know, I'm the scientific program manager for healthcare informatics research at VA.
Excuse me, I just wanted to make sure people knew that this particular presentation is being recorded. So if you want to cough like me, I'm going to have to cough during some of this. I'll try to do it, outside of away from the microphone.
Do they record in the transcript?
Don't say anything you'd want recorded for posterity. Is that what you're saying? Okay, thank you for the warning.
So the jokes, off-color jokes, that's a good idea.
Okay. It's been organized as a story, the prologue, the chapters 1, 2, and 3, and I'm going to give the prologue. So we are the nation's largest healthcare system, and we have the second largest funder of biomedical research in the federal government. And this diagram depicts our healthcare system in many ways. So we work with injured veterans. We work with mature veterans or treat them. We have that diagram on the upper right over there. Visualize our C box. So we have medical centers and clinics. We have inpatient care. We also have a major research program. And we also do wellness work with our veterans to improve health care. So we have 8.3 million enrollees, and they're served by 807 clinics at 152 hospitals. And we have a fully integrated health information technology system, better known as VISTA CPRS. This gives you a sense of the magnitude of our data that we have. And so the first column here is our VISTA data to date. And the second column is the number of entries we have every day during prime time. So you might want to take a minute to look at that. Matt is here because of the TIU documents, mainly, and the fact that he is an epidemiologist, public health person, who's eager to make great use of these data.
Mary, some of us non-medical people aren't quite sure, for example, what orders means in your regard, or TIU, as far as that goes.
Well, orders are written by clinicians, typically physicians, but not necessarily physicians, that prescribe a treatment, a diagnostic test, some other management decision. So those are executed by the healthcare team. So we usually think of orders as being associated with inpatient care and other types of orders on the outpatient side, mostly being prescriptions, other treatments.
Got it. Thank you.
And TIU stands for text
utility, text information utility. So it's a jargon. It's one of those acronyms in VA that just means that's what these clinical documents are called in VA. VISTA is the I think Mary mentioned the data system that VA uses to support electronic health.
That one I've learned.
Okay, great.
Okay. So when I came to VA in 2006, we did not have a healthcare informatics research program, and we launched it in 2007 with an RFA for natural language processing research. We funded it in 2008, and at the same time we funded Vinci. Some of you have heard me talk about that here. And this is a high-performance analytic environment with secure access to our corporate data warehouse and many other VA data sources. So in this since 2008, we've been working on recruiting informatics research expertise in this area. We've had great informaticians in VA, but what we've not had is a huge research force in VA in informatics, except the ones in Salt Lake. I don't want to leave them out. And I think we may have taken some away from NLM, but...
well, Ching Zhang is someone that we recruited to VA, who is also still NLM.
Right. So,
but also Guy DeVito.
Guy DeVito, I think, is the one I was thinking.
Ching doesn't work for NLM, but she's an NLM researcher.
Les Leonard part of it?
Pardon me?
Les Leonard involved?
Well, Les is with CDC.
I know.
And now he's in Salt Lake City. He's in Utah. So he's in the biomedical informatics department, a close colleague. I helped recruit him to Salt Lake City. And he is not directly doing a lot of VA work right now. Yeah.
Tom may actually have come to ask for his people back.
Tom knows Les very well, indeed.
And so I just want to say that I didn't put this on the slide because I wasn't expecting Tom, but in 2007, Tom joined us in Chicago for a discussion. We had Tom Ryan, I guess, as we talked about doing this research, and so he helped launch this research program. So he gets to find out what we've been doing today. So I'm going to turn this over to Matt.
Thank you. All right, now I have to stand. Is that it's hard for me to talk otherwise.
Oh, you're welcome to.
Okay. So let's see. So I want to say that I'm a big fan of This American Life and Ira Glass. My middle son listened to Ira Glass give a presentation in Salt Lake City, and so that's somewhat been an inspiration for organizing talks as narratives, and as chapters, different than that. So hopefully this will resonate with you. The other thing I wanted to mention is that just to tell you a little bit about my background. Mary alluded to it a little bit. So I'm a physician. I do epidemiology. My work is really the intersection between epidemiology and informatics. And so, in fact, we've had a lot of support from CDC as well as VA. We had Center of Excellence in Public Health Informatics. That's how I know Tom Savell, who's on the call. So, the chapter 1. So, the next few slides are going to describe what you may feel to be something of a diatribe against ICD-9 codes. But I want to kind of say off the bat that I'm not here to keep scorn and criticism on ICD-9 codes. Rather, I want to describe their limitations and describe ultimately how there's ways to help address those limitations. But I want to be clear that what I'm not saying is that ICD-9 codes are useless. In fact, we use them. I use them. They're very important. What I'd like to propose is that the problem with inability to scale, which has many different dimensions. There's a computational dimension. There's an analytic dimension. But what I'd argue is that there's a semantic dimension that is in part addressed by natural language processing. And some of the aspects of the semantic dimension are perhaps less well appreciated. And that's what I'd like to focus on. Some issues that I think sometimes may not get as much attention. So I'm going to present a hypothetical study. Again, keeping with the idea that rather than keeping everything abstract, it's nice to have something to fix ideas. Some example. The proposed analysis would be to examine alternative therapies, alternative antibiotic regimens for community-acquired pneumonia. And one of the controversies that exists in clinical practice now is just how broad spectrum do antibiotics have to be. And one reason why this is an important issue is that this is an arms race. The more broad spectrum the antibiotics are, especially the more we use broad spectrum antibiotics for empiric therapy, the worse problems get in the future, the more we select for resistant organisms, and the arms race continues. And as you probably know, we're essentially running out of new drugs.
Does community-acquired mean acquired in the hospital?
So community-acquired means patients who come into the hospital with pneumonia.
Already with pneumonia.
But a lot of these patients that come into the hospital with pneumonia have been previously hospitalized. Or maybe they had previous antibiotics or some other previous care. And so there's this kind of odd nomenclature that people refer to healthcare-associated community-acquired pneumonia, otherwise known as HCAP. And, oh, by the way, your question reminded me to say, I want to be interrupted. Please interrupt me. In fact, I'd be much better speaking if I'm interrupted. So, please ask questions, especially if something doesn't make sense. So this odd label, healthcare-associated community-acquired pneumonia, refers to these cases that come into the hospital with pneumonia, but have had some previous healthcare exposure. And those are the cases that guidelines have been issued that recommend very broad spectrum therapy. And so sometimes you hear the problem is not the evidence; it's implementing the evidence. Well, that's not really true. There's a lot of problems with the evidence, and there's a lot of problems with incomplete guidelines, lack of acceptance of guidelines, controversies around guidelines. There's a lot of gray zones in practice, and so this is just one of the areas of evidence that is in active flux, if you will. And so to do a comparative effectiveness study, I mean, you basically need at least these three types of data to be included. You have to identify a population that meets some criteria. You have to have treatments that you're comparing that you extract, and outcomes. Often it's just simple things that are easy to find, like mortality or length of stay. And then you need to account for the fact that this is an observational study and not experimental. So working in VA environment, 150 hospitals, billions of rows, one thing to mention is that, as Mary said, there's 8 million active veterans in the system now. There's 20 million veterans, unique individuals, 20 million unique individuals over the last 15 years of data. I mean, this is a really big population. All the outpatient care, all the inpatient care, all the progress notes, all the text documents, all the laboratory tests, everything. Everything done in VA. And so the opportunity to do statistically powerful, epidemiologically meaningful comparative effectiveness analysis is phenomenal. And it can be done efficiently because the data are electronic. And you're not going to do manual chart review of 100,000 patients. I mean, even the federal government can't afford that. And there would be significant benefits for practitioners. But what I would argue, again, referring to the semantic problem, is that there are fundamental issues that are not addressed based on kind of current conventional methods. So, there's a very commonly used, almost maybe even universally used algorithm for deciding who has pneumonia based on ICD-9 codes. And I think that, the question that I would submit is, people don't define what they mean by pneumonia. So the problem here is ontological. And so what we get from records, are linguistic representations. That's what language is. And those are recorded typically by clinicians. And the clinicians are describing their mental models. Their mental models are their interpretations of clinical data, of clinical presentations, of clinical phenotypes. The clinicians make interpretations that we call diagnoses, but that is not the same as what the patient has. The disorder exists in the patient. And there's a substantial kind of literature and body of knowledge around ontologies that addresses these issues. They're not appreciated in epidemiology. They're not appreciated in health services research. And connection between the disease or disorder and the diagnosis is often not even acknowledged. Now, so fundamentally, I mean, one then can kind of trace the limitations of that design code. I mean, everyone recognizes that they may not be reliable. They may not be matching what the clinicians assert, but they're also, it's just fundamentally not the same thing as a disorder. There is intrinsic uncertainty. There's intrinsic disagreement. There is a fundamental problem with using discharge ICD-9 codes to assess treatment decisions that are made at the time of admission when information is not available yet. The discharge diagnosis is the accumulation of data and information and interpretation made at the end of the hospitalization. The decisions about what empirical therapy to give are made at the beginning of the hospitalization. And we're assessing quality. We're doing comparative effectiveness based on final diagnosis, not based on information that's available to the clinicians who are making these decisions in the heat of the moment in the emergency department, for instance. But even, going beyond that, the reason why we do manual chart review is the limitations of ICD-9 codes for examining, stage, severity, phenotype, treatment response, besides just simple things like length of stay. The deeper problem, though, again, is without the analysis of what's recorded, we don't understand really the thought processes, the kinds of processes that clinicians are employing, the level of uncertainty that they have. And it's accounting for uncertainty, accounting for missingness. That's where the big data, analytics, natural language processing, all these different new technologies are important and will be significant. So, but at the very least, we need to use diagnostic test results. And those test results include text reports. And we'll give some examples of where we've extracted information from text reports. This is among the simplest, most straightforward applications of natural language processing. And in addition, we do need to apply NLP to these other types of documents that I list here. So before chapter 2, I'll take a breath and ask if there's comments. I'm trying to set the stage now. Yeah.
Okay, so clearly there are big issues, and this is a good example. Pneumonia is a good example. But how much, if you were more precisely identifying this diagnosis or dysfunctions, would you be able to do something about it, or do you think it would be useful to have it for data analytics in the future?
Well,
because
I think that there's so much information and knowledge that's sitting on the table that we have 2 billion, we have billions and billions of data points that are not being used. And I think this is just one aspect of that problem, I would say.
Actually, one of the problems I have is that we need to find some low-hanging fruits. So we can really demonstrate, okay, we saved so much money by being able to do this kind of analysis or whatever.
Right. Yeah, and I'm going to present some low-hanging fruit. I mean, they're really simple, obvious low-hanging fruit. I mean, and one thing I was thinking as I was kind of thinking about this meeting is that the best kind of NLP, the highest impact, is when the people that are using the products of NLP don't even know that NLP had anything to do with it. I mean, they shouldn't be aware of it. All they know is they're bearing those, they're enjoying the fruits of the labor. And so, the research scientists get into the details of the methods of how to apply NLP. But I agree that the low-hanging fruit really are simple things that are pretty obvious that just haven't been done. But there are more complex things as well, for sure. Any other questions or comments?
Is ICD-9 most of the code system you use CFPRS?
Well, I knew you asked about ICD-10 or something.
No, man.
Oh, yeah, right. So, right. Well, so, I don't know the details. I mean, that's not my expertise, nor am I involved in the operational side. I work with those people. I see those people. There are lots of those people around. But one thing that is relevant, but I don't really have any slides about it, is even where there's a lot of coding, it's often inconsistently applied across different VAs.
And there's not rich enough information, is what you're saying.
No, but there is. But this is where you need the NLP. I mean, so cutting
in the codes, there's not rich enough information.
Well, I mean, like, okay, just as an example. I mean, maybe I hope this partially answers your question. So we've done a lot of work with microbiology text reports, and so these are among the most complicated of all kind of laboratory tests. They come in stages, they have a lot of different parts of them, et cetera. And so there has been some implementation of SNOMED codes for organisms. They're inconsistently applied. Some of them are old. I mean, they're old, they use old versions of SNOMED. And so what we end up doing is, because we've done a lot of work with raw text reports from microbiology, we have to kind of extract different sections of those reports. We parse out different sections, organisms, the susceptibilities, the susceptibility results, et cetera. And then within those different sections, then we have to standardize to one code. So even though we'll see parts of SNOMED in those sections, but we standardize to current SNOMED CT. So our approach is to try to remove the variability that exists across VAs and across time, which is endemic or epidemic or pandemic, maybe in VA more than other places, I'm not sure. But so it involves these various steps of using NLP tools, some of which are pretty simple, but then also a lot of mapping, basically. Yes.
I think it's kind of interesting to me is, if I understood you correctly, that like a EHR record, EHR might have documented like the process of discovery, process of diagnosis.
Right.
And I guess what I wanted to ask, from what I understand in industry, I'm not sure if it's true in VA, that no matter what gets put in there, if it's not right or whatever, like legal purposes, I understand like cross stuff out. You can't just delete it and clean it up and make it correct. Is that true for these records as well?
Oh my gosh, that's a great comment. So first of all, I mean, people talk about medical records as representing a sublanguage, and there's actually many different sublanguages. Different specialties have different, and the language is terse. The language is sparse. There's so much implicit stuff. I mean, the expression of the differential diagnosis will be something like, X versus Z, and that's the thought process. Typically, or kind of more generally, because people in general are not verbose, but there's really interesting variation. I mean, some examples. So first of all, you tend to get really detailed representations or descriptions of symptoms in nursing notes. Because the nursing notes will have much less interpretation and much more kind of description of the raw experience. So that's very useful. Another thing is that in some specialty areas, for instance, we've analyzed these clinics called post-deployment clinics. And also, there are certain clinics that are devoted toward helping veterans that have war-related syndromes. And they have phenomenal notes. They have structures. They have a lot of rich structure, rich occupational history, rich military history. They actually ask patients questions in a standardized way. You find out in those notes what the patient's priorities are and values are, and what's important to the patient. It's not just the something that's kind of opaque in terms of, well, this is the clinician's statement of the principal problem. And then another kind of genre are mental health notes, which are just another kind of emphasis altogether different, really. So sure where I started with this, but basically, I would say that I mean, if you expect things to be documented well, you're incredibly disappointed. I mean, there's a profound difference between something being reported as not present versus something that's not being reported. There's a profound problem with copying. You'll see errors propagated through notes because of copy and paste, which is feasibly done and that's done. So, but it's fantastic for exploration. And so one of our big efforts within Vinci and Cheer has been to develop tools that allow exploration. And so I mean, from a research standpoint, again, it's incredibly fertile, but to get practical applications out is a challenge. And the big things take time. Okay. So this slide is my slide to the reviewers in the audience. Which is maybe not this group necessarily, although maybe you are reviewers, but I'm talking about the study section reviewers. But it's the comment that we get back sometimes from reviewers that, well, NLP, that's not very good. I mean, it's not very accurate. It's got mistakes. Which of course I say, well, so does everything else. I mean, so do ICD-9 code. But for more than that, I think the question is really not what NLP does by itself. It's what NLP does in combination with other methods, in combination with existing data that are structured. And so there's a kind of famous, informatics theorem, fundamental theorem from Chuck Friedman, that clinical decision support, computer decision support are computers better than humans. It's whether humans plus computers are better than humans alone. So my proposed modification of that is, in this case, I'm using the brain to represent language and linguistic representation, and the computer to represent structured data. So the argument is including the text data, the linguistic representation with structured data, I would argue, is generally better than structured data alone, even when the NLP isn't perfect, which it typically is. But we do need the analytic methods to keep up to help us understand how to deal with the error, how to deal with error, which we typically ignore when we do the statistical analysis. Given just conventional approaches, with conventional approaches. Okay, so here, I have a few slides that are, kind of general steps toward using NLP. And one reason why I'm showing this is that we spend a lot of time working with other researchers to help them understand the process. So I can't tell you how many times I've been in a conversation with colleagues where they go, well, that sounds really cool. I don't know how you do it, or I don't really understand it very much. So I don't know it's very foreign. Even though a lot of the tools that we use are actually have familiar analogs. Like annotation is related in part to manual chart review. It's also related to qualitative data analysis. But since these different methods are associated with different disciplines, the terminologies are different, and people get confused, I would say. So this first slide is really the ontological slide. So again, it's the plea, and I've gotten to arguments. This actually goes back to work that we did with CDC, where we used to argue about epidemiologic case definition. And, what were you actually measuring when you do an epidemiological case definition? And I feel that this is something, again, that we typically take for granted. We typically people typically don't go through this process formally. I believe it's helpful to be formal about it, because there's this kind of fundamental semantic confusion or lack of clarity at the beginning, then I think it kind of contaminates or it bleeds through the rest of the research if it's not taken care of at the beginning. So I think there's a fundamental difference between a diagnosis that's made in the course of clinical care based on information available at that time versus a diagnosis that's made to support an epidemiological analysis. Versus, again, what is truly happening in the patient, which is something that we generally cannot observe completely.
So that's basically three different definitions of the term pneumonia.
Exactly. That's exactly right. And I mean, this bedevils research, I would say, but I don't promise that this solves the problems, but I think that getting some clarity on this issue, on this fundamental issue, can be helpful. So, okay, so the next thing, the next step, I would argue, and although maybe the sequence here is not exactly the way everybody should do it or the way it should be done, but it's just, again, I mean, one thing that we're very interested in is, in the context of BA and CHEER and Vinci, is collaborative research, sharing workflow, doing kind of collaborative science, basically. And so some of that means this kind of meta research about what is our research process. And so again, that kind of motivates some of these slides. So again, the fundamental issue for text data, where the way I would describe it is that either we're essentially directly converting the text elements into coded data, often we call concept extraction, concept indexing, other terms, or we're applying some algorithm where text elements are used as inputs, as features into those algorithms, which is often a black box approach, as opposed to this approach, which is often where that coded data then just gets fed into explicit rules. And so the JAMA paper that was about post-operative complications, where NLP was used, is an example of this kind. Lots of examples of this kind as well. One thing that was done, so this is just as a kind of brief digression. We did a project actually with an investigator that Mary knows well, Sylvain DeLille, where at the Baltimore VA, where what he encountered, he's a pulmonologist and informatics researcher, and what he encountered was that he found that he couldn't get agreement about the reading of pneumonia from chest X-ray reports. Again, reflecting these fundamental issues of uncertainty. And so he decided that a useful approach would be, for the purpose of what he wanted to do, which was develop some surveillance systems, would be simply to classify a chest X-ray as basically normal or basically not normal. And so for that classification, we were doing a document-level analysis. We were not annotating individual elements within the reports, infiltrate that. I mean, what we essentially applied the pre-existing text processing system, and then we inputted all of those features, those text features, into a black box algorithm. And that system that we use actually is on Vinci, and you can use it. It's available as open source. It's called Automatic Retrieval Console, ARC, developed by Mendebolio, another VA person up in Boston. And so that's a system where we did a document level classification. So I think, again, the assignment of raw text data, these are two fundamental kind of approaches. And they obviously can complement each other together. Okay, so the third step here is that at some point there has to be some human review. I mean, the way we've approached this within Cheer and Vinci that we create an annotation service. And again, our goal is to develop annotated data as a resource that ultimately can be shared and reused. And these annotations are layered, and so they are cumulative in value. Something that has always struck me is that just how important it is to try to simplify the task to the extent possible. So a lot of that depends on exploration and iterative development. And there's a lot of people that I'm sure people in this room know, people like Wendy Chapman, done a lot of work in this area. And we have a lot of tools now to do annotation in VA. We have a chart reviewer tool that's like a simulated record. We have a new version of Notator. We have a new system that we call eHose. Wendy Chapman is developing additional tools. And we have also search tools. So we're using the name Google. No relationship to Google intended. And so these are tools that we're trying to get available to researchers and operational people broadly in VA. Finally, for this chapter, what I want to say is just that this is an aphorism from residency: see one, do one, teach one. It may not be relevant anymore because it's considered probably inappropriate care if you don't get enough. You only do one on your own, and then you're teaching somebody else. But this is what we used to say. So the training, the application, the development of rules, development of algorithms, there's a lot of pieces to NLP. And the goal here is not to describe the natural language processing pipeline, but to just to provide some overview, I guess. And so I'm just describing here the parts of a discharge summary that might be annotated by a human and then served as a training or reference standard for the computer system, for the natural language processing system. Okay, so now I'm going to shift to examples. Any questions or comments?
Your examples from the preceding page, are you looking for what I might call key words and or key sentences?
Well, I think typically I would say, and Tom was, I mean, look, it's like I even hate to even answer a question about natural language processing to a Tom Lang session.
I won't answer it.
But
I'm just setting him up so we can criticize him.
Well, but I would say that typically people are looking at noun phrases, but there's a lot of information in the verbs too. Okay, some things are easier to annotate than others. So take this sentence about smoking. I mean, so it's one thing to say, oh yeah, I mean, what this is what you find out is that it's incredibly difficult to create an explicit guideline or something, or an explicit way to capture all the meaning that we get from that sentence. The computers don't do this very well. I mean, computers are pretty concrete, I would say. So they don't get nuanced. So things that are kind of in a terminology, and UMLS, metathesaurus, are the easier things. I mean, I have another slide about this later, but we as Guy DeVita, who used to work for NLM, has done a lot of work on extraction of symptoms. And what we find is that there's incredibly rich, which is not surprising, is that they're in different places in the nose, there can be incredibly rich, what we call subjective symptom expression. The person, we have a paper actually that's in press now, we call pins and needles. I mean, so people may just, the person who, has nightmares may describe, climbing up on the roof and sitting on the roof all night long, or they describe, the elephant sitting on my chest. So they use analogy. They use, and the thing is, so it's interesting, this is really interesting. This is interesting to me. The first paper didn't get accepted for something submitted, so it didn't interest me, previous reviewers that much, I guess. But what's interesting to me is that it's meaningful to a clinician. If a clinician reads elephant sitting in my chest, there's an immediate inference, that sounds like, you can't even help it yourself. We have these associations with diagnosis that, these templates in our head, basically. And but when you code that, you code the chest pain. Well, you lost that. And so we think that there's richness that is lost when you convert text data into coded data. But it's also really hard to do the NLP on those subjective. So this was driving Guy DeVita crazy. He's trying to work with these complicated expressions. And it led to a lot of error in the application of our NLP system. That's an interesting issue. Do you have any comments, Tom?
Well, I guess I would say that it seems like, people, keywords and versus, say, relationships or something, or even higher level stuff like analogy. It seems like the VA, you say that here the emphasis is on practical application, so getting the highest accuracy you can, and the most accuracy is the keywords, right? And other people are doing that, but you're 100% right in the clinical text, especially because of all the implicitness, really, and the analogy that, there's so many inferences that there's been a little bit of work, I think in, I forget, with Gargano Sabova, what's the name, in Massachusetts, but really, if you're doing that with any degree of usefulness, it's very much still a basic research issue.
Yeah. Okay. Yeah. Thanks. Okay, so, all right, examples of these. So I mentioned microbiology data. So this was the information in a single field, in a single row of data. So this is the raw text report. This is what the clinician sees with cheap tear-outs when they open up a record. Of course, it's formatted more nicely for the clinician, but this is what we were getting in Vinci. And now, obviously, there are other, there are other ways. One doesn't necessarily always have to deal with these raw text reports when working with microbiology data. But this is what we had to deal with in our first foray into working with national BA microbiology. Since there's been some evolution since then, but this is still fundamentally actually important, as I'll describe in a little bit. But for the longest time, because of lack of national microbiology data, ICD-9 codes have been kind of the bulwark for doing surveillance for infectious diseases within VA, either ICD-9 codes or various kinds of self-reporting data. So, to make a long story short, we developed a pipeline that was pretty simple, but followed these steps that I described earlier. Now, what I don't show is a slide that describes, the accuracy. So this involves a lot of testing, a lot of different kinds of validation, which I'm not going to describe really. But what I really want to say is something as simple as this is I would say one of the biggest impact consequences of the Cheer and Vinci program, because it's really been taken, and this is one of those examples where it's been taken up by operational partners, and not to say what's also fantastic is that now other researchers can request these data. And, it's really fascinating because we spent a lot of time and we used money from a lot of different sources to accomplish this. And now other people are going to be able to catch up to us, but that's good. I get, I feel, one has that, information is always power, but then, but the spirit here is to create things that other people can use, and I think BA really facilitates that. So something that has, been a direct consequence of the Informatics Initiative funded by HSRD. Now, we've done other things that are not yet having the impact in terms of creating new data resources, but they have the potential. I mean, they will get there. They're just taking longer for various reasons. So, but these are also simple things. These are also diagnostic test results. These are also things that you can do very accurately with NLP. Just, coding and lymph node biopsy results, coding just some of the structure, some of the data, some of the numerical data, within echocardiogram reports. I mean, this is a little bit trickier. This was and also more interesting, but again, a couple of steps removed from implementation from practice. But this was driven by this was motivated by the desire to find out more information about device use in patients. And as you know, devices are a black hole. I mean, we have all this medication data that's structured, but almost nothing that's structured about devices, except in the context of a coded procedure. And so, one indirect way to find out whether a person has an intravascular catheter, central catheter, is through the chest X-ray report. And that's done routinely in ICU cases. Okay, so, but another kind of example of application of NLP is to assess treatment where treatments are not adequately, especially where they're not adequately coded. And so things like counseling, or an example of that. There's a lot of mental health treatments that are not fully coded, or even not, or maybe not coded at all. So here again, an example where natural language processing was used. The context here was a study about guidelines for management of gout, and just showing the high accuracy of the NLP system.
But does that mean that NLP processes came up with the same codes that others had come up with 98% of the time, or does it mean something else?
Well, what it means is that when the NLP system was compared to human annotator,
that's what I tried to say.
Yeah. So correct, you're right. It's really an agreement. Now, I mean, humans may be wrong. So really, the better way to express that is agreement rather than correctness.
Still pretty good.
Yeah, it is. But again, I mentioned symptoms. I mean, so symptoms are a larger, more complex task. But again, something where we believe by taking on something this ambitious, we can establish a resource that other people can use. Something that will be transformative. So I think so. This is my last slide. So here's the summary points. Basically, not to pile it on for IC9 codes, but to say we can do better, and we can combine the application of natural language processing to text data to IC9 codes and other structured data. And the other points I think we've discussed. So I really appreciate the chance to talk to this group. It's really fun. Thank you. But I probably can't fly here from Salt Lake City every time we meet.
Well, we're glad to get you at least once.
Okay.
On the general subject of semantics, one of the things I've stuck my nose into for the last few years is this IT system called the Semantic Web.
Yes.
Which has RDF triples and then other stuff on top of that. Does that enter at all into your dimension of things? And if so, what do you think about it?
Again, see, you ask me questions that I'm embarrassed to answer because of experts like Tom in the room.
I've already asked him. I need a second opinion. I'm checking up on Tom's answer.
So the thing is that I have to say, as a researcher, being a researcher is like, it's like you have this sense of appetite. You want to eat everything on the menu. And so, but there are some menus that I haven't tasted very much. One of them is, I haven't done a lot, I basically have no personal experience with the using NLP, applying NLP to against external knowledge resources. I mean, my experience with NLP, specifically, the application of NLP, the use of NLP, is really in the clinical side, the clinical informatics, not on, knowledge sources or internet sources. But having said that, of course, I'm like everybody else interested in what IBM Watson did and all that, and how it could be used in the clinical side. So I don't have direct experience, first of all. Second of all, I know people that do that stuff. I mean, and there's all kinds of opportunities for collaboration. I mean, one of our colleagues in Salt Lake is Guillerme
Guillerme Delfio.
So, he has a new grant, I think funded by NLM.
We were collaborating with him.
Yeah, I mean, but basically, he's one of the inventors of the so-called info button technology, which is a technology that links electronic health records with external information resources. So, potentially tapping into the semantic web. But so now what he's doing is kind of going a step. Traditionally, the info button technology has been used against structured data in the clinical record. The next step that he's going to follow is to connect text data in the electronic health record with information and knowledge resources accessible by internet or by the web. So that's a process that's starting now. It's a research study. We're actually collaborating with Guillerme we have a new project that's actually just funded by VA, and this is a little bit of an aside.
Got all the time you like.
So we have a new project in VA that ties a little bit to what you're describing that we call Bends Like Mine. So the basic idea is that we want to help clinicians deal with the situations where they're unfamiliar, where there's uncertainty, where guidelines do not seem to be applicable. And what we're proposing to do is, and what we're going to do is help a clinician find other patients like the one they're dealing with, to do essentially case matching to assemble, essentially to perform a query to assemble a cohort that allows them to tap into the collective experience of other VA clinicians. Again, 20 million patients, thousands of clinicians. And so to make a long story short, this is something that that has many steps to it, and it's an idea that we think has great traction in VA, and it's really also a great example of use of big data. But also it's something that should tie into these other external information resources. And so we're actually collaborating with Guillerme on this. And so I see the semantic web as something that connects to what we're doing with the clinical record, but it's just something that is not my own particular area.
Sure. So let me ask one follow-on to that, and I'll give you my pedestrian interpretation of semantic medline, and I can be tapped on the shoulder when I get it wrong. But you're absolutely right that the semantic medline or semantic web is these days mostly used with structured data.
Yeah.
My perception is that semantic medline is a bold step into using semantic web type technologies in the text environment as opposed to the structured data environment. And I can't even get the creators of the structured or the semantic web to want to talk about natural language because they think it's too hard. And yet here it's being done right under our noses. So the fact that Tom can, he takes three things, right? Takes the NLP, which is a sine qua non. Takes the UMLS, which you damn well have to have. And then you can take this third thing called the IT system of semantic web, put them together, and get wonderful metadata based on key concept sentences. To then tie together all these abstracts that are in Medline and everything that follows from that. And I guess so with that lengthy prologue, I guess what I'm wondering is it doing the same thing with clinical notes? Is that feasible? That Tom has been doing with journal abstracts.
I should answer that, because the thing is, it is, but it's going to take, it's going to take a push and an effort to do that. You can't, in order to really get relationships out of clinical data, largely because of the implicit nature. The thing is, the information is assumed, it's not explicit.
The elephants, rather than...
Well, not only that's analogy, but not only that, but the relationship isn't explicitly expressed. Or the thing is, there's things like, these are things you have to realize. We do inferencing all the time. The sort of thing you say, aspirin for patients with headache. You haven't really said that the aspirin treats the headache, and maybe it doesn't, because if you say aspirin for patients with AIDS, you're not taught. You assume the physician knows. Patients with AIDS have special cases of headache, and so will it work or not? All these things are magnified hugely in the clinical text. I think two of the comments I can make, George, to take Matt a little bit off the hook on this, it's very interesting that you would mention their collaboration with Guillermo del Fio is, I think, maybe an instance or the test case of what probably the proper use of NLP is here, because the thing is, for people who are actually exploiting the NLP, it's maybe too much to ask that they're the ones that also do the basic research like we do at NLM. But Guillermo del Fio is what he's exploiting. So he's exploiting our database, which is in the literature now. He's making connections between the literature and the text, and then he didn't have to go out and do 20 years of semantic processing. he can use it. So I think what's interesting, but I think also another comment I would like to make just about the VA and the work that Matt is spearheading at Utah, George, is it's an excellent example of, and I think the VA is really to be commended on, is taking. So the idea of this of low-hanging fruit, I think, is very important. So you're not in it really to develop NLP technology. You're saying to exploit what's there, and then what can we do with it from this practical point of view. So I thought your talk was very illuminating to me, because I basically have my head in semantics, but I don't really know exactly what I could do with it.
Right.
So it was very interesting to me to see what you really can do with it, and you put this in a very nice context of this, the semantic and the ontology, different, all that things are not often realized. And then seeing the stuff that you really have creating, I think is all very good, and can be a first step. Then just because we can't do reliably. The people that are trying it with machine learning are not. It's not going to be reliable enough to really be useful. And broadly enough, what you can do with semantic relationships with the projects have been so far has been very, very limited. So smoking cessation or obesity things. And okay, it works for that, but then how do you put it to anything else? So but what I think what's good here in the way to look at this is that what the kind of things the VA is doing. Once the linguist can solve getting relationships out of clinical text, then we'll use it. You've got the whole machinery in place to use it, and then it'll fit naturally in the semantic web, because of course the predications are RDF triples. So we're kind of still building the pieces that at some point will cooperatively work together, but they're both necessary.
Yeah, it'd be so fascinating to generate some questions from the semantic web that we then try to test in VA or vice versa. It'd be really interesting, I think, to look at where there's maybe complementarity in terms of in terms of hypothesis generation versus other things.
Yeah, that would be good. And the other thing is, I think there's other work done on the prospects of sort of getting high accuracy relationships or predications out of clinical text. What are the prospects of doing that? And there's there's two, I think, avenues that people take. One is that some parts of some records, at least, are real complete sentences with nice, like discharge summaries typically are often written as we say. And we tried that with some, we do quite well on that. So maybe start with those. Another thing is that people like Sergei Pakomov at University of Minnesota is working, and we collaborate with him on that too, is that you sort of say, well, okay, like for example, what drugs is a patient taking? Well, usually they don't say right out in a way that they would say in the literature, this patient is taking this drug. The drugs are listed here, the problems listed there. But we have worked on saying, okay, if you take statistical processing and get this drug associated with this disorder, this symptom or something, and then Well, might or might not be, though. But then if you also go and compare it to a statement from the literature that says this drug is used to treat that disease, then that ups the possibility that that is a predication in the clinical text.
Right.
You see, so there's a bunch of creative sort of things that could be done that, and then you guys could exploit. And the major thing is you have so many not only tools, but you've got sort of application areas where you're able, I presume, to demonstrate to physicians and healthcare workers and like this so that we can really use them.
Yeah.
Is there a movement back on the medical side to make these records and entry? Well, especially with electronic entry.
Right. We'll never be like we'll never go to Alta. I mean, that's really a great question. I mean, because it seems like the obvious thing is to have clinicians input very structured data, but they obviously don't like to do that.
Say they'll
right.
They'd rather just
Sure.
dictate.
So I understand they're building tools that would, as you're inputting it, it would do structural interpretation, and you get to read that interpretation so that both what the clinician actually writes is there and the interpretation is there, and you can approve or disapprove that interpretation.
So there's a lot of templating. I mean, so the one thing that makes NLP hard in VA is that these notes are heavily templated and inconsistent in variable weights across the system. So, but yeah, go ahead.
I was wondering if there's anybody online that had a question.
Yeah.
Please speak up on the telephone if you have any questions. Hearing none, we'll proceed.
So, just to amplify George's question, of course, solving the semantic interpretation problem is still a huge issue for all of us, but it clearly some advances can be made already, right? And that would be useful in actually solving specific problems that could be implemented in the so my question is, it would be nice to identify those specific issues that you have brought up and that would be benefiting from semantic interpretation, because I despite of the fact that we have this schemas and techniques, for clinicians it's much more work to write their own and then check the interpretation, right? So it would be very much nicer if we could have sort of deeper knowledge implemented in this.
Yeah. I mean, I think that. Maybe there are some really important points there. I mean, I guess. One thing that's. I think that. A lot of our focus has been on use of NLP to improve the quality of data, the richness of data that's accessible for analysis. So, the online analytical type work. Less of our focus has been on the kind of real-time use of NLP to support the text documentation or to provide clinical decision support at the point of care. But I feel that the methods we're using will ultimately be applicable at the bedside. But it's more complicated in VA or any healthcare system, because anytime you're changing process of care, you're going through a lot of levels of review. It's very expensive. There's many moving parts. So one of our low-hanging fruit aspect, kind of, I guess, emphases is let's do the stuff that improves the value of the data that exists for quality monitoring, for surveillance, for health services research, for epidemiology, for comparative effectiveness, and eventually it's going to get into the hands of the clinicians and the hands of the patients at the point of care.
You're certainly right about we're going through a transition. I'm afraid to admit to clinicians that I'm a computerist, because then I get a half-hour lecture on how they only see half as many patients as they used to, because they spend all the rest of their time trying to enter these fool records.
And it's all your fault.
That's one of the things I think to remember about entering structured data. It's very time-consuming, actually.
I know.
And they don't like it.
They all complain about it.
They don't like it.
Well, to sort of put Mark's previous question in the context, I think the solution, with my tongue firmly in cheek, is to invent a programming language and teach all the clinicians to use it, because I assure you the semantics of programming languages is a whole lot simpler than the semantics of natural language.
Yeah.
Well, you know, it's really funny that actually, a computer scientist recently said to me, we were laughing about computer science, you know, as opposed to just about everything else, and he was saying that in computer science, only very general solutions are considered to have value. And so in computer science, you could discover the cure for cancer, but you still wouldn't get tenure because it would be considered a one-off.
So there's one more question that kind of bothered me for a while now. Clinicians are trained by different, depends what they train. Einstein, they train.
Right.
And
it's a guild.
And for whatever 6 years of their residency, would it be useful to detect those styles and use those to actually make more accurate interpretation of the notes, because they have been, in other words, the training influenced the way they enter the notes.
But I missed that. So say that again.
So the training influences how they the patient, but also, I assume, it would influence how they enter their notes.
Right.
And the question is, could we use that knowledge
Yeah.
of the style or whatever
Right.
as a contextual variable that would enable us to do better interpretation of NLP?
I can respond because some of the times we have explored what the possibility of applying our techniques to clinical text, and that's 100%. That's 100% right. I mean, not only not only what school of medicine they did, but what specialty are they in?
Right.
And so it's in what that makes a huge difference in being able to read and interpret notes. And the point is, but I think this is what the discipline in the field and the funding agencies are not. They want a quick fix in processing clinical notes. They don't want to take the time. You've got to amass that knowledge. You've got to structure it. You've got to make a system know when it needs that knowledge. And we actually, I mean, I'll plug them in. We put a paper in my group and at Amy processing some of the most difficult kind of text. This is the stuff that encodes LOINC notes, so it's laboratory tests and stuff and what they put. And we just did a test case to show you that, okay, in order to do this, you need to know all of these various things, and there's just no way, I mean, unless you're a physician. So, sure, we could do it, but somebody's got to support it.
But I think
and the whole point is you're absolutely 100% right. You need knowledge. You need knowledge of various types at various times during the processing, and you have to have that knowledge. And right now, the knowledge isn't.
Right.
It ain't just the text, it's the context.
But semantic web would be helpful.
But you have to realize, just because you know English doesn't mean you can read and understand the text on microbiology. And what
what I would say is that, I mean, the way I look at it, I mean, maybe this is not the answer to the wrong question, or not the right answer to the right question, but I would say that what we should do is, I mean, we should recognize that clinicians are fallible experts, and that basically, that one thing we want to do, obviously, is support the expert, the cognitive process of experts. I mean, and so, we need to design, cognitive support tools that support that cognition. But some extent, what we want to do is make it easier for us, and make it easier, make the process more transparent, so that ultimately, we have a kind of better measurement mechanism. But I think so. So here's an example of what I'm trying to say. I think sometimes a non-clinician may want the clinician to pin the clinician down. I'll give you two choices. Which one is it? And that can be very cognitively difficult. We probably shouldn't be. That's probably the wrong question. People. The questions and the information that we elicit should tap into what is really going on when the clinical decisions are made. For example, I would argue that the diagnosis is not really separate from the treatment decision. So what we've observed, for example, is that if the clinician is going to give the patient antibiotics, they tend to give the patient a diagnosis that warrants antibiotics. And so
because it's experimental approach, right? You try that and see if it works.
But a clinician has to what a clinician cannot do is sit around a table and discuss methodology. A clinician has to, it has 5 minutes, 10 minutes,
justify their action.
Yeah, and the only problem is that.
Well, they have to make an opinion that is partly true themselves, but it's also responding to the patient. They're responsive to the patient. They're reading the patient. But it's very, it's very practical, very concrete, and so when it would help the clinician and would help us to develop better kind of support tools is to understand where are the biases that are kind of contributing to problems. Where it's not. Again, it's not this kind of simple linear make a diagnosis, decide on treatment. It's this kind of synthesis process that is not well documented and will not be easy to document in details. I don't know, maybe Tom is
Well, I think comment for now. This is right where we should take off for the beer.
but maybe Tom is developed.
Maybe Tom is here.
Good. All right. I think Meg's right. This has been a wonderful discussion, and we'll finish the rest of our agenda now. You're more than welcome to listen in and kibitz as you see fit, and then we'll adjourn to a happy hour afterwards where we can continue the discussion. And if you can stay for that, so much the better.
Yeah.